SQL Edge to Cloud with Bob Ward.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. ClearMeasure is hiring architects and .NET engineers who would like a path to become architects. And then finally, our last announcement, be sure to check out the new video show, Architect Tips. And we'll get right on to our guest today. I have with me Bob Ward, and he is a principal architect for the Microsoft Azure Data team, which owns the development for all SQL Server versions. Bob has worked for Microsoft for 27 plus years on every version of SQL Server shipped from OS 2 1.1 to SQL Server 2019, including Azure SQL. And Bob is a well-known speaker on SQL Server and Azure SQL, often presenting talks on new releases, internals, and specialized topics at events such as Red Hat Summit, SQL Bits, SQL Intersection, Microsoft Inspire, Microsoft Ignite, many different virtual events. And you can also learn Azure SQL from him on popular series with Azure SQL for Beginners. That's aka.ms/Azure SQL, 4 beginners. And you can follow him at Bob Ward MS or on LinkedIn. And he's also an author of the books Pro SQL Server on Linux, SQL Server 2019 Revealed, and Azure SQL Revealed, all from A-Press Media, and also a Dallas Cowboy fan. Bob, welcome to the show. How are you, sir?
Jeffrey, thank you so much. I need to have you write my resume. That was a pretty glorified introduction to what I do. People ask me what I do for a living that are not technical people. I'm like, I don't really know much anymore. So, wow, I need to have you be the one to introduce me now when I go to an event. But yeah, thanks for having me today.
Yeah, we could call you Mr. Database.
Yeah, Mr. SQL.
Mr. SQL, awesome.
Bob SQL.
Well, one of the things not mentioned here, you'll be speaking at the DEVintersection Conference coming up in Vegas this December.
Can you believe that we are actually going to go speak at an in-person conference? We actually had a kind of a hybrid version of it in June in Orlando, and we've rebranded it the SQL Server and Azure SQL Conference as part of DEVintersection. So you had DEVintersection, there's a SQL part of it. We kind of branded it SQL Server and Azure SQL. And yeah, I'm very excited to get a chance to go there. We'll be talking about everything SQL Edge to Cloud there. So it's pretty good stuff. Can't wait to see you there in person as well.
Yeah, it'll be my first in-person conference in a year and a half or so. So it's gonna be good. It's gonna be good. Now, there's so much about SQL Server, whether it be on a virtual machine, a full Windows server, or in Azure. But at the same time, you guys are casting a pretty lofty vision for just database and SQL Server as a whole. What do you mean when you talk about edge to cloud? What is the overall vision?
Makes sense to ask that question, Jeffrey, because it sounds glorious, but in practicality, I'm a very practical, technical person. What does it mean? If you think about SQL Server, you talked about my career at Microsoft. It's my 28th year at the company, and I started out at Microsoft with our very first version on OS 2, if you can believe that, running on Pentium computers back in the days. Diskettes, the whole thing, right?
Nice.
To where we are today. We just started out as a relational database engine, kind of like on departmental servers, doctors' offices, you kind of name it, and then got some reputation later on in the enterprise. So where we've evolved today is we really believe we have a very powerful database engine and a very powerful database platform for developers that runs everywhere from a drone, a Raspberry Pi, an IT device, our actual engine running on these, all the way to running very large applications in public clouds like Azure. So it's kind of our intention to show up where customers need us. I have this, mantra where I say SQL is everywhere you need it, but with compatibility with the same T-SQL language, compatibility with tools, with features. literally the code bits that run SQL Edge to cloud, Jeffrey, are the same bits. We'll tweak it here and there depending on the scenario, but we do have like a main code tree for the SQL engine where all this stuff runs. That's why we can achieve such great compatibility. But it started out with just that relational engine and just grew into, well, why don't we go run this on Linux? Because everybody wants us to run on Linux. Why don't we run in containers? Why don't we run in IoT devices? Oh, maybe we should run in public clouds as well. And then even hybrid scenarios. So it's just built up over time, this portfolio. And I call it Edge to Cloud because, again, it runs this gamut of IoT edge devices, on-premises, hybrid scenarios, and then in public clouds.
There was a conversation, it seems to have fizzled out a few years ago, but it was the NoSQL movement. And now we have SQL Server, and people were saying NoSQL, but it seemed like what they really meant was, wait a minute, no. We just don't want relational. We want a document database, or we want a JSON or whatnot. And now SQL Server does all that stuff too now, doesn't it?
Yeah. That's why I call it a data platform, because we still believe that the T-SQL language is the best language people know and love. So anytime we build things like whether it's graph databases or JSON support, it's all about extending the T-SQL language and have the engine have the built-in capabilities. For example, we even adopted the ability to run machine learning services with R and Python, running machine learning models on the same computer as the SQL engine, co-located with it. But the way you run those models is you install them and execute them to T-SQL. So that common language has really been beneficial to us because people don't have to learn a new language. You just learn some of the extensions to a great language you already know and love. So yeah, there's no question that there are several different databases out there that call themselves like a NoSQL database, and they serve great purposes for developers. But we kind of feel like we serve a lot of purposes and can still provide the functionality you're talking about.
Well, from a development standpoint, there are times when you realize, I can't get SQL Server to run here. So now I have to invent new data layer patterns and new ways to store things. And now, do I need to think about transactions here because I don't get them for free? For instance, the new Blazor WebAssembly applications. Well, if I can't run SQL Server inside WebAssembly, well, now, I got to think of all this stuff anymore.
Right. Yeah, I think Linux is a great example where back in the day, 2016, 17 timeframe, we just felt the market was ripe for us to enter the Linux world, right? Not as an open source database. We still have a paid database service, but we felt we could provide some things that customers were telling us they didn't have. They were using Postgres, MySQL, other types of Linux open source databases. They just weren't getting the scalability they needed, and they weren't getting the enterprise support. These are small companies that were growing up and getting bigger that all of a sudden realized our entire business is running on this database. And if we have a problem, what do we do?
Yeah.
So we decided to enter the Linux market, and it's a very innovative technology that we built. And that allowed us also to enter the container market, which really opened up new possible developer scenarios for us. I've got all sorts of great stories where customers who are tried and true SQL Windows customers, now they develop SQL containers. It could be on MacBook, for example, right? But it's all compatible. So they just build their app with SQL containers. They could even use DevOps with Azure DevOps doing this. And then they'll just, take that code and run it on SQL and Windows and Enterprise Server, and it all just works. So I think the Linux container model was a huge part of that edge to cloud journey that we made.
Now, you called SQL a platform, not a database. And so there's some fairly new things, Azure Arc and, of course, Linux and all the SQL versions in Azure. What are the main components now of the SQL platform?
Yeah, thanks for asking that. When I talk about the platform, the reason I say that is that the core engine, just like an engine you have in a car, right, is all about the basics of security, performance, and availability. Like our engine has to provide and support the T-SQL language to do all those things. But then surrounding it is the ability to run it on these different scenarios. Let's take Edge, for example. So customers came to us and said, IoT is exploding on us. We have a lot of telemetry from these devices, but we have semi-connected scenarios where I can't just feed a bunch of telemetry to the cloud all the time and get what I need. I need to do machine learning prediction on the device, but I need a database engine to power that. And we said, well, we kind of have machine learning tied in with our database engine. We can just go take our engine running in a container and an IoT device, even on ARM devices. We can integrate in streaming analytics. So you can literally on the device now write some code. You can develop it anywhere you want, bring it to the IoT device, And now this device can do, again, like machine prediction failures through models that you've already trained on the device without even being connected anywhere to the cloud. And then when you're ready to connect to the cloud, you upload the results that you're seeing, right? It's a great example of innovation where we took the core engine and just said, oh, the core engine gives us all these great capabilities. Let's put a platform around it to solve a specific industry problem.
And where does Azure Arc fit in?
Yeah. So you think about in your mind, visualize, this edge to cloud thing. We'll start at the bottom and talk about edge and talk about SQL Server on premises, which is where we've been running our bread and butter for, a quarter of a century. And then think about Azure SQL running the SQL database or a SQL instance in the public cloud. We had customers that said, I love the Azure SQL idea. I love the platform as a service concept. I love automation of backups and point-in-time restores and high availability and versionless SQL servers. I don't even want to patch anything anymore. Those are all cool. I cannot afford right now in my business to go to the public cloud in Azure. What do I do? And we're like, there's this thing called Kubernetes, which is a pretty slick software service, right? Running on hardwares of your choice. It provides some foundational platform capabilities like what we do ourselves in Azure. What if we built a set of software services on top of Kubernetes and then let a customer deploy that anywhere you want? Ford's a good example of that. Ford is a great company that came to us and said, we run your product everywhere, but we love that Azure thing, but there's certain applications that cannot run the public cloud. Give us that software to automate some stuff. Let us run in our infrastructure. And we're like, okay, I think we can do that. And so thus was born this idea of Azure Arc enabled SQL managed instance. It's like SQL platform as a service, but you run it wherever you want. And so through a series of Kubernetes pods and container images, we do all this automation for you to make that all possible. And then Azure Arc is an overall branding at Microsoft where it's not just us. You can do Azure Arc Kubernetes or Azure Arc Windows servers. So Azure Arc is a brand, and that word arc doesn't mean like a circle. It means like arcing, like a hybrid connection between you and Azure. So, in the case of Ford, they can say, oh, I'll take my Kubernetes and I will semi-connect this to the cloud and I'll take advantage of all these services you're talking about. And they'll even integrate this in the cloud in a way, and get ready for this. I'll get billed for SQL Server based on cloud subscription, even though I'm not running it in the cloud. So now all of a sudden, that's pretty amazing. So for the first time, we are offering SQL Server as a service running in your infrastructure where you're billed like the cloud instead of paying for like a license over a period of time.
Yeah. Okay. Yeah. Smaller instances really benefit from that.
You absolutely.
Whew. Okay. So whether it be on your own infrastructure or on the edge devices, I'm curious, how does SQL Server actually get installed on all these other devices that are not Windows operating systems?
Right. It usually comes down to containers. So first of all, in Azure SQL, as you know, like anything in Azure, it's based on Azure Resource Management. There's an infrastructure there called Azure Resource Management. And we as the developers at Microsoft just snap into that. The Azure team provides that to us. That's why you can go to the portal, click a few buttons, and behind the scenes, we're just installing a SQL Server for you. It just happens, right? So deployment there is a very simple, automated way of doing things. So for SQL Server on Edge or Azure Arc, we make it also simple through the ability to use container images. And container images are really powerful for us because they're pre-deployed, installed versions of SQL already done in the form of a snapshot of a file, right? So you use whatever process you would normally use to install a container image. If you're using a Docker engine, Docker pull, you just can run the container down. In a Kubernetes environment, as you may know, Kubernetes provides interfaces for you to easily deploy what's called a pod. And in the pod, you just say, here's the container images I want as part of my pod. So for Azure Arc, we just put tools on top of that to say, give me a managed instance through a single command line interface. And then boom, we do all the behind the scenes. We'll just use Kubernetes to do that for you. Or this is where it really comes cool. If you're connected to Azure with Azure Arc, you can do it in the portal. So you can go to the Azure portal. Yeah, this is crazy. You can go to the Azure portal. You already got your Kubernetes cluster connected to Azure. There's a process to do that. And then all of a sudden you can say, oh, I'd like to deploy my Azure SQL managed instance on the Kubernetes cluster in my infrastructure. We will push down the container images to your environment and just deploy it just like you were doing an easy cloud deployment. So I think containerized images is one of the ways that we've simplified this environment when you're not doing a standard Windows server or Linux server deployment.
And are those containers, are they all Linux or are they also some Windows containers?
Right now, they're all Linux. The Windows container market, the Windows container paradigm appeal has not really, flourished in our opinion. So right now, when you run Azure Arc SQL Managed Instance, you are running a Linux container image, but here's the beauty, you don't know it.
Yeah.
Your interaction with this is just like a SQL server. You would use Management Studio or your apps or your tools. You don't even realize this is a Linux container running in the background. Kubernetes is part of that abstraction, obviously. But yeah, it's all Linux container-based right now. And then, of course, if you're using Azure SQL, you don't know anything that's going in the background. You're just running our platform as a service. Now, we do have Azure Virtual Machine. That's a very popular, it's really important to point that out, Jeffrey. That's a very popular part of the SQL Edge to Cloud story because we have a lot of customers right now that are looking at Azure. They want to make that move of their SQL servers and their data center to the cloud, but they feel like I need a very quick lift and shift way of doing this. I just need to take my SQL running in VMware and stick that into Azure. And we have a lot of tools now that really make that a very fast process to do.
Oh, there's tons of applications where the application has to be on the local network of the database for latency and whatnot. And we just don't have time to re-architect it. But if we could lift it all over, well, now it's on the same network again, as opposed to a wide area network hop.
And not just that, what we see is, this is a perfect example. ISVs will say, we've certified our app on SQL Server 2016 only. You can't go past that.
Yeah.
Right. And that's fine. We have other things we're trying to do to help move that forward. But that's when a customer say, look, I need to be in the cloud, but your platform as a service is ahead of that. It's a versionless SQL Server. So you're well ahead of 16. So we use Azure VM in cases as a bridge. Customers will lift and shift to Azure VM. They're running SQL 16. They own the entire VM, maybe still even like on Windows 16. The app all works great. It's all compatible. And then at some point, they work with the vendor and say, yeah, you know what? They can support now managed instance, for example. And we have an online way of migrating that. So you move to VM, you take your backups and put them into Azure storage because you don't just keep them on a local disk drive. Once you start doing that, we have a process to take your backups and automatically deploy those to managed instance and then do an online migration cutover. So you keep your managed instance up to date while you're still working on your VM. And you say, look, I'm ready to cut over. And within minutes, you just point your app to managed instance and you're up and running. So
nice.
Think of that edge to cloud story now being, I'm running on premises. I move to Azure VM. I stay there for a bit. I start replicating to this managed instance platform as a service, and then I cut over when I'm ready.
I don't know if this is exactly related to that, but I've heard the term sync, not replication, not mirroring, but this new synchronization. Is it totally new, or is it just being deployed in different ways?
So for SQL Server and Azure SQL technologies, there is a technology called replication, and that is the ability to take the transaction log, have processes that run on SQL servers, and send commands like SQL commands to another SQL server called a subscriber. And you keep things in sync, in quotes, by using this technology. We've had that for a very long period of time. I worked on the early days of that technology way back.
That's right.
Decades. Yeah, we had it way back, right? So what we did in 2005 is introduce a technology called database mirroring. That's morphed into a technology called always-on availability groups, which we've had since SQL 2012. And so 2012 and onward, we have this idea of doing a sync replica. So think in terms of a SQL server running on one machine or VM, another SQL server running on another VM, usually a very fast connect between them. And you say, hey, my transactions are not going to be committed until we've synced on this secondary. So I know that if I had to fail over to this other one, I don't have any data loss, right? So what we've done is take that technology and automated that in places like Arc and in Azure SQL. So for example, you go to Azure SQL Managed Instance. You say, I want to have that. I'd love to have that synchronization failover concept. You pick what's called a business critical service tier. It's like a declarative thing. Just give me a business critical service tier. You pick a checkbox, say, I want this. Behind the scenes, we'll just build this for you. We just have all these replicas running, already ready to go, synced. And then we just continually keep that running for you. You even get the ability to read from one of these. So you offload your read queries from your operational data to another one of these. That helps you be more scalable. And then we provide this failover automatically if we determine the problem. The cool thing about Azure SQL, as opposed to, say, running on Arc, is that we provide a guaranteed service level agreement. So we have a certain number of nines. You've heard the term nines, right?
Yep.
We have a certain number of nines we maintain as part of the contract with you. And if we violate that, we give you money back. Like we have a big incentive to keep this thing highly available for you.
Right.
With Azure Arc, we'll still automate the availability group technology for you. But since you own the infrastructure, you have to own the SLA, because we can't guarantee what's going on with your hardware or what's going in your system. But we will still provide that same built-in availability group replica technology where you don't have to manage it. You just declare what you want, and then we sync to these replicas for you automatically.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, on Edge, you mentioned, I'll just pick one of the ones that I thought I heard. You mentioned Raspberry Pi, installing the SQL engine. Does that support this new synchronization?
Not yet. Okay. Today, you would not set up one of these Raspberry Pis as a primary replica for one of these synchronous replica technologies. Technically, you could put that together and manually do that yourself. What we found if customers are doing in those scenarios are they don't really want to do that. They want to take the results of what they're processing on the Pi. Let's say it's a machine in the machine plant. They're going to take the results of the processing and they're going to feed those to like an IoT hub device.
Yeah.
Okay. So there is synchronization going on, but not through SQL, through a different mechanism. Or you could do something like Azure Data Factory and then take these IoT devices and synchronize those to an Azure SQL database or a managed instance. So the synchronization happens a little different there. And the reason I say that is that nobody's looking to take the IoT device and fail it over to another one. Right. If the Edge device fails, the customer usually has other IoT devices that back up the processing of that, like a machine or a drone or whatever you want to call it, right? So you don't need that SQL replica thing. You need the ability just to take your data and replicate it to a cloud device somewhere so you can process the results through like analytics.
Sure. Okay. Well, part of your vision, I could see some people, and this is where my mind went as well, because some of the applications that I have is if I could replicate a single small table, well, now all the work to have a durable queue, that's potentially a replacement for. It sounds like that's not part of the vision for the SQL Edge.
No, I think you can do that. There's different ways to pick and say, I'd like to have a single table, replicated per se, right? Today with Azure SQL database, with managed instance, with Arc, you just pick it on a database basis, right?
Gotcha.
But if you wanted to synchronize just a single table, you have technologies like change data capture. So the SQL engine does provide technologies already built in that says, just take the change feed of a single table, and I'm going to take that and replicate it somewhere. So we do have APIs for developers to go do those things themselves.
Mm-hmm. Okay.
And that works with Edge, by the way. You can do that even with Edge.
Okay.
Right.
Okay. Nice.
Because it's part of the engine. It just comes with SQL.
Nice. Now, you are actually giving a keynote at the DEVintersection Conference, Microsoft SQL Server and Azure SQL Futures.
Wow. Am I? I better get ready for that.
Yeah. Well, are there things that are coming out next year that are already announced that listeners should maybe start playing with, or do we need to wait until the DEVintersection Conference to hear? Yeah,
it's kind of hard to give you the punchline, right? Our intention there is to come to an event like that, which again, it's so amazing to be back in person. I've been speaking at it used to be called SQL Intersection for a decade or more now. Paul Randall and Kim Trick used to run that part of this event and always invite me to come. It's so nice of them. And there was a point in time when they said, "Hey, would you start being our keynote speaker, because you're always in the forefront of our technologies and working the engineering team." So that's really our intention, is to come to the event and just give you the latest and greatest of everything we're working on. As you know, in the cloud, we're constantly innovating that. We have that ability in the cloud to, it's a version of SQL Server. We can push new enhancements and changes in weekly if we wanted to, right? And we have these different preview phases and so forth we can put customers through. And then SQL Server, of course, we're always trying to take a look at how do we innovate that technology. So if you think about a future talk, it's exactly what you're going to hope for. Like it's one of those things where I have no idea what Bob's going to say, but I am going to sit on pins and needles and listen to what's going to happen because I suspect he's going to talk about some stuff that hasn't been talked about before. So that's really the intention of what the session's all about.
Okay, good. Now, I have to ask anybody who talks about database or any other technology, what is the latest and greatest method for deploying changes? And so, DACPAC has been around for a long time, but some of the other guests on the show that work on SQL have said that they use Roundhouse or DBUp or, a SQL script-based approach. What are the discussions within the team, or maybe the vision for the different ways going forward for deploying changes to a SQL Server database, as well as the schema that it houses?
Yeah, mirroring that together is always the tough part, right? Mirroring changes that you're making for that. But what we have found is really those are typically decoupled because unless you have data that's like reference table data that your app as a developer you build, the changes of data happen naturally as part of just the app, right? The data itself is separate from a schema change, right? Or a procedure change or something, right? So it turns out that I think Azure DevOps has some really great possibilities there. Number one, we've got a better story now of integrating Azure DevOps with Azure SQL Database. We've got some demonstrations. You can just go look that up. I got some colleagues of mine that spent a lot of time on that space. I demonstrated last year at Build how to take containers as a way to integrate with Azure DevOps with SQL Server. So imagine you using Azure DevOps to deploy changes you're making that are like, say, app changes or even schema changes. And because you're using Azure DevOps, we will automatically deploy SQL containers to go run tests for you against that based on a known version of SQL. That's super powerful because Jeffrey, let's say you're doing this and you're like, look, Bob, I have to make sure that my schema changes and my app changes will work with SQL 19 cumulative update 10 or something like that. Like that's the latest one we're working on. You can declare that all with Azure DevOps. And then behind the scenes, we'll automatically deploy the containers, run the tests for you because you told us what SQL script to run. And then you can automate what should the test results look like compared to what they normally should look like. So those two scenarios are ones that we're really pushing for from that perspective. It would be Azure DevOps with containers and with Azure SQL Database.
Okay. And you mentioned tests. Just curious, and maybe this is too far in the weeds. For the actual SQL team themselves, is there a particular test framework that seems to be prevalent for?
Yeah, definitely. On the SQL Server side, we use exactly what we just talked about. We use containers. We use a very large scale number of containerized images to be able to go successfully test the engine. Now, there are some scenarios that are specific to Windows that containers don't support yet, that we have to go have other automation to just run Windows VMs to do those kind of testing. But for a lot of core engine things, we can use a very large number of containers to do testing. And then the Azure infrastructure itself, we have a very robust platform to do testing for Azure SQL Database and Managed Instance, where we have deployable, easy ways to deploy those images in test Azure regions. If you know what I'm saying, like think of Azure regions like we have our own test regions where we can go deploy these things and run automation. There is no way today that we could support the millions of databases in production we do in Azure SQL if we didn't have that. The developer team, it's very much a DevOps approach in the Microsoft engineering team for Azure SQL. The devs are on the hook to support this thing.
Yeah.
You're a dev, I'm not going to do anything manually, man. I'm going to automate the fire out of this thing. So the automation behind the scenes to verify, test, do canary testing, all of those things is extremely robust in Azure SQL. And we've built our own framework and infrastructure to do that. We've also share other frameworks with people in the entire Azure team. There's so many Azure teams at Microsoft now. So it's not just us. Right. Because remember, one of the things about Azure SQL, we're a big support mechanism for Microsoft. You name it, SharePoint, Dynamics, all these first-party services use Azure SQL behind the scenes. Right. So we got to make sure it works for them.
Right.
So we have a big incentive to make sure those frameworks work really well.
Well, there was a point in time when the ASP.NET team had their own internal test framework, and then over time, they basically shared what became the XUnit framework, and now tons of .NET developers use it. Is there a particular framework or library like that inside that y'all have a vision for sharing in any way, or is that really just internally kind of homegrown for the SQL Server platform?
Yeah, not for SQL Server specifically. It is interesting you say that though, because there are a couple of tools that we take advantage of that I've worked on myself in the past in my career at Microsoft and can use for like scale testing. So there's a really, really fun tool called Ostress. You ever heard of that?
No, tell me about it.
Yeah, Ostress, Ostress. So I'm a senior person. You get to tell stories when you're a senior guy, right? Yep. I'm sure we'll run out of time here. But, so just real quickly, myself, a colleague of mine named Robert Dorr and Keith Elmore were working in support in the day. And it was our job to break SQL. That was our job, nice. Break SQL, based on what customers were telling us. And so my friend Keith Elmore and Robert Dorr, super smart developers on their own, they just said, I'm tired of running a bunch of manual scripts. I'm going to create a multi-threaded app that can take a SQL statement and run it any way I want it. 100 threads, X iterations, interject cancellations and timeouts and all sorts of types things to make it run however we want. So we built this tool called Ostress a long time ago. It is still our bread and butter. Like we use it internally within the team. If you ever see me do demonstrations publicly, when I show like a workload, which is like, hey, I've got a workload running like 10 users, I always use Ostress. Because literally I can take any SQL command and feed it to this thing and say, hey, go run this 1,000 times with 50 users concurrently. And in the middle, kill yourself, after 10 seconds or something.
Yeah.
Super powerful tool. It even has some crazy ability to replay things. It's got XML language. You can replay stuff. I mostly use it just for like this ad hoc, run a bunch of workload type things. So we also have, as you may have heard, our benchmarks. So TPC benchmarks are traditional benchmarking for Microsoft. We still use those tried and true to do benchmark testing to see how fast we can run. But we also use it to do stress testing against the product because we have discovered through analysis that running those benchmarks exercises some really important parts of the engine. So we still can use those. And then we have some other internal benchmark testing as well that can do. We have this thing called Robert Dorr, my friend Robert. He works on something called long haul testing, where he has a series of tests he's built, a lot of times using Ostress, and it's just using customer scenarios and SQL commands and all sorts of stuff he's learned over the years to go with the intention of breaking the product. People don't like Robert sometimes because he breaks the product.
Because he finds the problems. Nice.
Exactly. But check out Ostress. Pretty cool stuff.
Yeah, and I found an article on SQL Server Central about it. We'll make sure to include that in the show notes. That's
the community, because I started doing after we built this, I started getting out on the road, showing this off. And all the MVPs were like, what is that?
Right.
I'm like, oh, it's free. Just download this ODBC-based tool and just run it. And they were just loving it, man. So yeah, it's been great.
Well, let's close on a question I like to ask a lot of guests.
Sure.
In your area, let's just confine it to Azure SQL. If someone's creating laying out a new architecture, brand new greenfield, cloud native application, and they're thinking, okay, I know I want to use SQL Server. There's all these flavors, managed instance, serverless, or all these different choices. If they're just going to have a 100% in the cloud native application, is there a go-to version or configuration of Azure SQL that that you would pick first? Maybe over 50% of the time you want to just grab this one, unless you have specific requirements and you know what they are.
Right. Yeah, I would say it's Azure SQL Database, and I've spent enough time now studying Azure SQL Database compared to SQL Server for the last couple of years. If I had a cloud-born app, new developer, one just out of the gate, just run it, and I just want to get a database, worry about my app, and let Microsoft handle availability, scalability, security, all that stuff, there's no question it's Azure SQL Database, because it's exactly what it is. Just give me a database and auto scale it for me, and let me get to 100 terabytes. And by the way, let it run serverless for me.
The serverless one. Okay.
Yeah. And by the way, all the availability stuff, all the backups, all the failovers, all that stuff, can you just handle that? And then me just rely on it. It would hands down be Azure SQL Database. And here's the other reason why. Let's say I'm a SQL Server developer. I'm like, I only need about 95% of the surface area of the T-SQL language, let's say in general. Maybe it's even lower. Maybe it's 85. I don't know. That's what I normally use. But Azure Database has it already there. It's all there. All the stuff you need is just all the query processors the same, indexing is the same, all that kind of stuff. Oh, and by the way, would it be nice if Microsoft could put some machine learning as part of me buying this behind the scenes? And can you tell me what indexes to run and build? Oh, wait a minute. Can you just build the indexes for me and maintain them? Yeah, that's part of Azure SQL Database. So I'm a developer. I don't want to worry about indexes. I don't worry about backups. Build the app. I want it to scale for me. I want it to, by the way, if I'm not using it, I want it to pause and not pay for it. That'd be kind of nice. Azure SQL Database has all of that stuff. So that would be my choice for sure. And I'm a SQL Server guy. I'm biased. I love SQL Server on premises, and we have all the power of everything you need in SQL Server on premises, but you have to manage a lot of it, right?
Mm-hmm. Oh yeah.
Here's a case where you're a cloud-born app. We have private link for ultimate secure connections. You want to run totally in the cloud. It pretty much has everything you need.
And you're specifically talking about the serverless configuration, not the managed instance.
Well,
right?
So let's just be very clear as we end here today. So there's Azure SQL Database and Azure SQL Managed Instance. Managed Instance is a complete SQL instance. It feels like a SQL server. We will automate behind the scenes availability, some of those kind of type things, right? But Azure SQL Database comes with options it doesn't have, like serverless and hyperscale. You don't get those with Managed Instance. So serverless, for example, is going to offer you the ability to say, hey, I don't even know how many CPUs I need. Can you just give me a range between 2 and 40 and just scale when I need it?
Yeah.
And then, by the way, if I don't use it overnight, can you just idle this thing down for me and me not pay for it? That'd be kind of nice. Or in hyperscale, you say, well, I think I need like a 100 terabyte database at some point. Can you just scale that automatically to that level? Sure. You pay for what you use, but that's what Azure SQL Database does for you. And again, your focus is just a database. You don't manage a SQL server. Azure SQL Managed Instance, you still have aspects of the instance itself to manage. Although we will automate still for you high availability, backups, those kind of type things.
Nice. All right. Well, man, this is a lot of information packed into this interview. I appreciate you coming on the show. Thank you very much.
Jeffrey, let me call it one last resource that you're going to love based on what I just said to you. Go check out Azure SQL Fundamentals.
Okay.
I know you had in your show Anna Hoffman recently, and the two of us partnered together to build a Microsoft Learn Path, what's called Microsoft Learn Path. So get ready for this one. You go there to Azure SQL Fundamentals, you go through our modules, you get a free Azure database to do this. You don't pay a dime. You can learn what I just told you about developing for Azure SQL Database in a learning module without paying any money. We've had people go through this process and be ready to go build an app now just by doing it, or get certified with Microsoft Azure certifications. It's really great resource. It combines itself with that thing you mentioned earlier, Azure SQL for Beginners is the YouTube video series that is partners with this. So you take the Microsoft Learn modules, you go through the exercises, again, you don't pay for anything, and then you go watch us with 62 videos, learn Azure SQL for Beginners. We modeled it after Python for Beginners, which is a very popular learning series. And we had just so many people love this because it's just an easy way to get started. You're a developer, you're an administrator, you don't know anything about Azure Database or Managed Instance. This is the quickest way to get going.
Nice. Yeah, we'll make sure to include that in the show notes for sure. Awesome. Well, thank you very much for this. A ton of information, and we appreciate you coming on the show and sharing what's upcoming. And listeners, if you were thinking about signing up for the DEVintersection Conference, by golly, go do it, and then you can shake Bob's hand in person in Vegas. So, Jeffrey,
thanks so much for having me. As it turns out, at that conference, Ann and I will be doing an in-person, hands-on workshop for Azure SQL modeled after what I just talked about. So if you want to be in a room with us and we teach you exactly what we built, we will be there to do that as part of one of the workshops for the conference. And thanks so much for having me on your show, and look forward to seeing you in person in Vegas in December.
Very cool. Absolutely. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.